How to test integrated hardware and software in electrical engineering. Have you ever wondered how engineers ensure that hardware and software work seamlessly together? Testing integrated hardware and software in electrical engineering is a vital process that confirms both components function correctly as a complete system. This process begins after testing each hardware unit and software module separately, focusing on their combined behavior in real-world conditions. The testing process typically unfolds in several stages. First, there is subsystem testing. Here, each hardware component, like sensors and microcontrollers, along with software units such as embedded firmware, is tested independently. This step ensures that everything meets its specifications before moving on to integration. Next comes integration testing. This stage combines the hardware and software components to verify their interaction. A popular method used is hardware-in-the-loop testing. In this setup, real hardware connects to a simulated environment that mimics real-world inputs and conditions. For instance, if a microcontroller controls a motor, it can be tested with a simulator that generates sensor signals. This allows engineers to observe how the software responds to hardware signals without needing a complete physical prototype. Once the subsystems are integrated, system integration testing occurs. This step assembles all components to confirm that the entire system meets functional and performance requirements. Engineers run comprehensive test scenarios that cover both normal and edge cases to validate that the system behaves as expected under realistic conditions. Key aspects of integrated hardware and software testing include using real-time simulators and test rigs. These tools replicate physical system behavior, enabling safe and repeatable testing of embedded control systems. They generate electrical signals and sensor data to challenge the software logic effectively. Automation is another important factor. Automated testing frameworks manage test execution, data collection, and result analysis, which improves reliability and efficiency. For example, test controllers can run multiple hardware interfaces and software scenarios automatically, speeding up development cycles. Creating an integrated verification environment early in the design cycle is also beneficial. This helps catch interface mismatches or timing issues before costly hardware revisions. The environment should be cycle accurate and capable of running real-time operating system software components. Timing and performance validation is essential. Testing must ensure that software processes inputs and controls hardware within required timing constraints. This is particularly critical in embedded systems that manage power electronics or motors. Lastly, iterative testing and feedback play a significant role. Test results guide design improvements in both hardware and software, reducing the risk of failures in later stages or in the field. Practical applications of this testing approach are seen in automotive electronic control units, aerospace flight control systems, industrial automation controllers, and power management devices. In these cases, integrated testing ensures that embedded software interprets sensor inputs and commands actuators correctly, maintaining system safety and functionality. Testing integrated hardware and software in electrical engineering involves a systematic approach that includes hardware-in-the-loop testing, automated frameworks, and thorough system integration testing. This ensures that the combined system meets design and operational requirements effectively.